Right, good morning, everyone.
Morning.
How are you? Sorry, I'm late. Yeah, okay. We're looking at the consolidation activity today. We need to revise that one. Right, so we're gonna go over that one. Okay, so I'll start with the multiple choice. All right, let me just record this meeting here. Okay, right. So we start 1.1. An object is positively charged, it is more, right? If an object is positively charged, what does that mean? It means there are more electrons than protons, right? There are more if it's positively charged, there are more protons than electrons. If it's negatively charged, then there are more electrons than protons. So A is incorrect because here there are more electrons, so it must be negatively charged. The next one, B, electrons than neutrons. Neutrons are neutral, so B is out. Then we go to C, protons than electrons. That should be the correct answer there. All right, then your D, protons than neutrons, that one is out as well. All right, we move on to the next one, 1.2. The unit of charge is measured, the unit of charge measured is called, this sentence here doesn't sound right somewhere here. All right, but unit of charge, what do we use for unit of charge? We use coulombs. We use coulombs. Right, so the correct answer there is B. Ampere is for current, volt is for voltage, watt is for watts. We use them for power. Right, next one, 1.3. A rubber balloon obtains a negative charge after it has been rubbed against human hair. Which one of the statements below best explains why this happens? All right, so you've got your A, negative charges are transferred from the rubber balloon to the human hair. B, positive charges are transferred from the rubber balloon to the human hair. Positive charges are transferred. Positive charges, they don't move. What moves is negative charges. So basically here, B and C, they're incorrect because protons, they do not move. What moves is electrons. So your answer must be between A and D. All right. A rubber balloon gets a negative charge. So it has got more electrons than, or more negative charge than positive. So negative charges are transferred from the rubber to the human hair. This is incorrect. It's supposed to be transferred the other way around. So negative charges are transferred from the human hair to the rubber balloon because the rubber balloon is the one that became negative, right? So your answer there is D. Then we move on to 1.4. 1.4, four identical balloons, each carrying a charge, are suspended from a ceiling, as shown in the diagram below, right? This one here, I think I'm going to take a screenshot, then I just explain using this. Okay. I need to explain this one here. I need to write something on this. Okay. Right. Okay. Just a second. Right, my system is a bit slow. Yeah, here it comes. Okay. Where's my smart note here? Just a second. I'm just trying to open something here. Okay. Okay. I'm not sure if this is the one. Okay, let me. I'm just trying to open something. Just a second. Yeah, here it is. Okay. So Right, so basically what we have here, 4 identical balloons, each carrying a charge, are suspended from a ceiling as shown in the diagram below. So balloon B is negatively charged. Balloon B is negatively charged. So it means this one is, sorry, it's negative. I need to remove this. It's negatively charged. Okay, all right, so I write again here. So B is negatively charged. And when we look at A and B, there's an attraction taking place. All right, so it means these must have opposite charge. So it means A is positively charged. All right, if A is positively charged, what is happening here? We see C is moving towards B. And if B is negative, then what does that mean? It means C must have opposite charge of B. So this one is also positive. And we see between C and D, they are repelling one another. So it means D is also positive. So your answer A is positive, C is positive, and your D is also positive. So that's how you get your answer for this one, yeah. Right, then we'll go back to the question. Right, we check which one is the correct answer. So our answer, that is all positive charges, it's your B. So A is positive, C is positive, D is positive. So your answer is B. The other ones are incorrect. All right, then we move on to the next one. 1.5, study the following sketch showing two charged spheres that are brought into contact and separated. Right, so you've got 3 coulombs and the minus 4 coulombs. They are attracting, so they are sharing charges here. The following is correct for A and B after they've charged each other. So basically what you're going to have to add the 2. So you're going to add the 2, 4 minus 4 plus 3, which gives you -1. -1 coulomb divided by 2, which gives you -0.5 coulombs each. So your answer becomes B. Your answer would be B. They're gonna repel after they've got the same charge, the same amount of charge, then they repel. So all of these, this one is wrong because nothing is changing here, right? This one, both neutral, 1 each. So your correct answer is gonna be -0.5 because you have to divide the -1 by 2. So C and D are incorrect. So your answer is B. Right, then we move on to question number 2. Question number 2. Number 2, what does it say? It says a neutral plastic ruler becomes charged when it is rubbed with a woolen cloth. After rubbing, the ruler has a charge of -3.5 times 10 to the power -15 coulombs. Distinguish between a neutral object and a charged object. Right, we check. A neutral object has equal amount of protons and electrons. So in a neutral object, the number of protons are the same as the number of electrons. Your positive charge is equal to your negative charge. Then a charged object has either gained or lost electrons, or you can put it in another way to say it has got more protons than electrons, or there are more electrons than protons. Or you can say you can just simply say the number of protons are not the same as the number of electrons. That would be a charged object, right? Then we move on to the next one. Does the ruler gain or lose electrons? Does the ruler gain or lose electrons? So we go back to the question here. A neutral plastic ruler becomes charged when it is rubbed with a woolen cloth. After rubbing, the ruler has a charge of -3.5. So initially it was neutral. Now it's negative, right? So if it becomes negative, it means electrons moved to the ruler. Right, so it became a negative, meaning it gained electrons. So your ruler gained electrons. We check the memo, it gains electrons. All right, we'll move on to the next one. Calculate the number of electrons transferred during the process of rubbing. Calculate the number of electrons transferred during the process of rubbing. right? So you have to calculate your number of electrons, N, right? So what you're gonna say, your N is equal to Q divided by the charge on an electron. All right, so here they've used E. I think in my handout they say the N, Q, and QE, which is the charge on an electron. So other sources would use E, which is still fine. All right, then you substitute. All right, but if you check on our answer, our charge on the plastic ruler, it was a negative, right? But in the substitution here, we no longer have a negative. So it means the negative was ignored here. But you can still put your negative and put the charge on an electron again, which is a negative. Then the negatives, they cancel. Then you're going to end up, you must always have a positive number of electrons here, right? It must be a natural number, right? So you're going to have a positive answer, right? So when you divide the two, then you get your 21,875 electrons. So 3 marks, 1 mark for formula, 1 mark substitution, 1 mark answer. All right. Then now we go to the next one. The charged ruler is now brought close to pieces of paper. The pieces of paper attached to the ruler is shown below. So you have your ruler there and you've got your paper. Explain why the pieces of paper are attracted to the ruler for 3 marks. All right. We check the answer then. When the charged plastic ruler is brought close to the uncharged pieces of paper, the paper is polarized. So here the paper is neutral and the ruler is negatively charged. When you bring a charged object to a neutral object, 2 poles, 2 regions of separate charge are induced or are formed. So you're going to have one side with positive, one side with negatives. So when you bring a negative, it means the positive are going to go towards the ruler, right? Then the negative are going to go on the other side. So the paper is polarized. The negative charges on the paper are repelled by the negative charges on the ruler. This leaves the side of the paper closest to the ruler positive. So this is how you explain the polarization of the paper. So that's how it is attracted. Right, then we move on to the next one. Name one application of electrostatics in our daily lives. Just one, right? We spoke about the spray painting in the handout, right? Where you do spray painting using a charged object so that the paint can be sprayed evenly and can stick to the surface. So we have also here in a photocopier, there is electrostatics. We've got fingerprinting also. Then you also have spray painting, just to mention a few. There could be more applications to this, right? So anyone that you mention, as long as it's applicable, then you get the 1 mark. Right, then we move on to the next question, number 3. The diagram below shows 2 small identical spheres, P and Q, on insulated stands. The charge on the sphere P is -3 times 10 to the power -6 coulombs. And the charge on sphere Q is unknown. All right. So you've got the scenario there. 3.1, calculate the number of electrons in excess on sphere P. All right. So you're going to take that number, you substitute a formula for number of electrons is equal to charge divided by the charge on an electron. All right. Or is equal to N multiplied by QE. All right, so let's have a look at the calculation. Your Q is equal to number of electrons multiplied by QE, where QE is the charge on an electron. You substitute the given charge, which is -3 times 10 to the power -6, is equal to number of electrons multiplied by -1,6 multiplied by 10 to the power -19. All right, then you divide both sides by the charge on an electron, then your answer becomes 1,88 multiplied by 10 to the power 13 electrons. Your answer here, please be careful here, it must always be a positive, right? Because these are natural numbers, so it must be positive. It cannot be negative. You cannot have a fraction here. You cannot have 0 comma. So please make sure your power here is always a positive number, right? So this one is more than a trillion electrons, more than that, right? So that's what you have. We'll move on to 3.2. The two spheres are brought into contact and are then returned to their original positions. Each sphere now carries a charge of -1 multiplied by 10 to the power -6 coulombs. All right. Calculate the original charge on sphere Q before the spheres were brought into contact for 3 marks. All right. So here what do you have? You've got the final charge on Q, right? On Q, then you've got the initial charge on P. You don't have the initial charge of Q. So the best formula to use would be Q is equal to Q1 plus Q2 divided by 2, all right? Because now we're going to apply this one here. We need to find the other charge. So you're going to say Q is equal to Q1 plus Q2. Or you can say Q is equal to QP plus QQ. Or charge on P plus charge on Q divided by 2. So Q becomes the final charge that we have after the charged, then separated, which is -1 times 10 to the power -6 is equal to original charge on P plus the charge on Q, right? Then you divide by 2, all right? Then from here you cross multiply. You're gonna cross multiply. You multiply -1 times 10 to the power -6 by 2. Then you divide by -3 times 10 to the power -6 for you to try to get the charge on Q, all right? This one, please don't get confused. It's Q2 charge on 2 or Q charge on a second object or charge on object Q. It's not Q2 divided by Q, so don't make a mistake here. Is equal to 1 multiplied by 10 to the power -6. So this is the original charge that was on Q2 before they combined, and then they shared the electrons, then they repelled one another. All right, next one. It says where electrons transferred from P to Q or from Q to P during contact. So what you need to check the charges here. This one is negatively charged. And in our calculation here, we see that our Q2 is positive, all right? So when you look at this, it means electrons moved from the one that is more electrons to the one that is less electrons. So Q has got more protons than electrons, and P has got more electrons than protons. So electrons always move from the one that is more negative to the one that is less negative. So the electrons will move from P to Q. So your answer is P to Q, not Q to P. Right, that's what we have there. P to Q is your answer. Right, then we'll move on to question number 4. Two identical insulated spheres, X and Y, suspended by threads from a ceiling, are held at a small distance apart, as shown in the diagram below. So this is what you have again. You've got a 4 times 10 to the power -18 coulombs, X, and your Y, no charge. This question is similar to the top one as well. All right. Then sphere X carries a charge of 4 times 10 to the power -18, while sphere Y has an excess of 30 electrons. So the difference between the two is the top one were not given the electrons that were there. All right. So it says 4.1, calculate the magnitude of the charge on sphere Y. So we're going to use the electrons to calculate that. Q is equal to NQE. So we move on. So we're going to have our number of electrons is equal to charge divided by electrons. All right. You substitute your number of electrons you have, that is 30. You're looking for Q. Charge on an electron, you're always given on the formula page. So you've got your -1,6 multiplied by -19. And please note here, your negative here, you don't ignore it, because we want to know whether Q is positive or negative. So you cannot drop down the negative. You have to include it. So you're going to cross multiply, then your answer there, your charge becomes -4,8 multiplied by 10 to the power -18 coulombs. All right. Then also the formula there, if you use electrons, it's also acceptable. All right. You also do the same. But here, it seems they are accepting. So it's just accepting this, but It's incorrect here because this charge is supposed to be negatively charged. Since there are more electrons, there is an excess of electrons. So this one must be negatively charged. Then your Q is going to be 4,8 multiplied by negative 18, then that's what you get. Then you go to the next one, 4.2. Give a reason why spheres X and Y move towards each other. Give a reason why spheres X and Y moves towards each other. As you can see there, the +4, the X is positive and Y is negative. And we know unlike charges, right, they attract. So the reason they move together, is because they've got opposite charge, and the opposite charge attracts. So that's what we have. Unlike or opposite charges attract. For 2 marks, you get that. Then we move on to number 4.3. The spheres are allowed to touch each other. After touching, they move away from each other. State the principle of conservation of charge in words. All right, so we have the net charge in an isolated system remains constant, or the total charge in a closed system is conserved. All right, so you can state it differently. They mean the same thing. All right, as long as you include those words that are underlined there, then your definition is correct. All right, then there's a note here when there's some person who's marking, if any of the underlined words or phrases are omitted in the correct context, -1 mark. So here you're gonna get maybe 1 out of 2, but sometimes they just say either you're right or you're wrong. Either especially with definitions, either you have a correct definition or you have an incorrect definition. Right, we move on to the next one. Calculate the charge on each sphere after they have separated. That's easy. So here you're just gonna use your formula. Q is Q net or Q final is equal to Q1 plus Q2 divided by 2. So you add the charges, right, that you have, the initial and the other one. For P, was it X and Y? Right, it was X and Y, right? So it's X and Y, right? So you use that, then you add the 2, right? After adding, you divide by 2, then your answer becomes -4 times 10 to the power -19 coulombs. That becomes the solution for 4.4. Right, move on to the next one. Question number 5. Number 5, almost the same. Okay, almost the same. 2 identical spheres A and B are suspended on long silk threads, as shown in the sketch below. The spheres carry charges of 3 times 10 to the power -6 coulombs and -2 times 10 to the power 6 coulombs, respectively. All right, which spheres? Which sphere has an excess of electrons? Which sphere has an excess of electrons? All right, so you check the one that is negative. All right, the one that is negative is B. So B is excess electrons. All right, 5.2, the 2 spheres are allowed to touch. Will the spheres be, will the electrons be transferred from A to B or B to A? All right, will the electrons be transferred from A to B or B to A? Like I said, electrons are always transferred from the one that is more negative to the one that is more positive. So electrons will move from B to A, right, for 1 month. All right, 5.3, the spheres are now separated. So this is not a question here. So this 5.3 is not here. All right, so it says 5.4, calculate the charge on sphere B. The spheres are now separated. Calculate the charge on sphere B. So what are you going to say? You're going to add the 2 and divide by 2. So your answer then, you're going to divide your 3 times 10 to the power -6 plus -2 times 10 to the power -6 divided by 2. Then you get your answer 5 times 10 to the power -7. That will be your answer for this one. All right, then you move on to the next one. That's 5.5. Calculate the number of electrons transferred during contact. Calculate the number of electrons transferred during the contact. All right, so here what you're going to say, for this particular one, you need to do the difference, all right? Because electrons that are transferred, it was when the initial charge and final charge, you have to find the difference between the two. So you're gonna, let's say you're looking at object, let me just go back to this question here. Let's look at B. B, the charge initially was -2 × 10⁶ coulombs. Right? Final charge, you're gonna use the answer that you got on 5.4. So the answer that we got on 5.4 was 5 × 10⁻⁻7. So you're gonna subtract the final charge, which is 5 × 10⁻⁻7 minus the original charge on that sphere. All right. Here you can use either. You can use the first one and the last one. Sorry, you can use like you can use charges for A. The final charge for both spheres is the same, which is 5 × 10⁻⁻7. So you can say the final charge minus the initial charge. You don't have restrictions. You can use A or you can use B. The answer is still gonna be the same. So you're subtracting 5 × 10⁻⁻7 minus this charge here, or you can say 5 × 10⁻⁻7 minus the charge on A, which is 3 × 10⁻⁻6. All right. Then the answer that you get, you now divide it by the charge on a single electron. All right. And charge on an electron is -1,6 × 10⁻⁻19. Then you get your answer 1,56 × 10⁻13 electrons. If you use the other option again, you're still going to get the same answer. Then you divide, you still get the same answer there. So there's no restriction here. Either way, it works, provided you're using the numbers correctly. So you use the final charge from 5.3 minus the original charge, then you divide by the charge on a single electron. That's what you get there. All right. I think that's all on this particular activity. Yeah. All right. Any questions? Any questions? Hello? Any questions?
No, sir.
Okay. Right. So you
No,
guys,
sir.
okay. You guys, you mark that activity, then you give yourself the marks that you are obtaining from that. Then I'm not going to continue because the next topic, the next section that we're doing, it's electricity. So we're supposed to move on to resistance. We need more time to do that, right? So I'm not going to move to that. I think we've a few minutes left. We've about maybe 10 minutes. Right, but for now, Monday, I'm going to be going back to work. And I'm not sure at 11 what is it that we're going to be doing, whether we will be having a meeting or something. But if we don't have a meeting at that particular time, we still have our lesson. So please, Monday, let's meet again, same time at 11. If at all I've got a meeting at that particular time, I will send a WhatsApp on the group to let you know that I'm busy. Maybe we schedule it to another time or we move it to another day. And I'm not sure as well how we're going to be working from school, whether we're going to be following our timetable from school on Zoom or something like that. I'm not sure. I think everything will get it when we get back to work. But I think Monday is going to be meetings and meetings there. So most likely our lesson might be disrupted, right? So you guys just keep the that space open for a lesson at 11, right? Anything else that you want to ask? Hello? Anything else?
What for electric circuits, what is meant by work done? Like, what is that exactly?
Work done is simply energy. It's simply the energy of the cell. So Remember, energy is measured in joules, work is measured in joules. When you are doing work, you are transferring energy. So basically, work done simply means the energy needed to move the electrons around the circuit. So your work done is work done by the what is it? By the battery to move the electrons from low potential to higher potential, basically. Or yeah, that's it. That's it. Yeah. So work done
Sir,
is the energy needed to move the electrons. Yes.
sir, my question, sir, can I ask,
Yes.
since like there's like a few learners like participating in like these Zoom classes,
Yeah.
does this mean like when we get back to school, you're going to have to repeat everything?
Not necessarily, isn't it? I'm recording them. So basically, when we go back to school, I'm gonna make them available. Maybe they put them in your laptop so that they can go over them. But where maybe learners are having challenges, yes, we're gonna have to go back and explain everything.
Okay, sir.
So,
Yes.
could you send me like the videos you recorded in the past so I can post on the channel?
Okay. What I'm gonna do, I'm gonna put them on Google Classroom. Because
Yes.
the files are too big, I can't send them on WhatsApp. So I'll put them
Yeah,
on
it's
Google
fine.
Classroom, then you can take them from there.
Yeah.
Yeah, I'll do that. I'll try, but the previous one didn't work out nice, so it's gonna come in two parts because I was cut off because of my network. So I'm gonna send it in two parts, but I'll label it first part and second part, or yeah, I'll label. I will try to label them according to what we are doing. Like this one that we have here, I'll label it revision of the consolidation exercise 14. Then you know which one is which one. Yeah,
Okay.
yeah, I'll do that. Okay. Any other question, Owen? Do you have a question? Yeah. I see our numbers are
No, sir.
decreasing. Only it's only 5 of you. I'm not sure why others are not coming through. Maybe data issues or something like that. I'm not sure. Sepang, any question?
No, sir.
Okay. All right. Okay. If there are no questions, let's adjourn the meeting. Let's meet again on Monday. Monday we continue with the electricity. We move on to resistance. Is that clear?
Okay.
Okay. All right. You guys enjoy your weekend and the rest of the remaining part of Friday. Right. Be safe. Okay. Bye.